Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important questions of normal approximation to binomial distribution. And this is the condition of the approximation. Both NP and NQ are greater than 5. I discussed these things in detail in my first lecture. Make sure you have watched my lecture 1 of this chapter, the normal distribution. For this lecture, I am using the work of one of my best students, Ms. Sharika of class 2020, the Lyceum. An important advice for me and for everyone, we should always dress properly. This is the index of this book. We do continuity correction when we do normal approximation, and this is the formula of Z, and this is the condition of normal approximation. This is question number 1 of this book. On average, 2 apples out of 15 are classified as being underweight. Therefore, the probability of underweight apples will be 2 upon 15. Find the probability that in a random sample of 200 apples, this is n of binomial, the number of apples which are underweight is more than 21 and less than 35. This is more than 21 and this is less than 35. So, we do 2 important things during approximation. We first draw a number line for the continuity correction. So, the first possible integer is 22 and the last possible integer will be 34 according to this inequality. So, you need to mention these 2 numbers here, 22, 35. Since you are going here, therefore you have to take lower bound of this number, which is 21.5. For 34, since you are going on this direction, so you have to take upper bound of this number, which is 34.5. And this is NP, and this means NPQ. So 21.5 is here, 34.5 is here, this is NP, this is NPQ under root, this is NPQ under root, and this is NP. When you will simplify, this step is of 2 marks. Make sure you must mention under root here and you must do correct continuity correction. Your continuity correction must be proper and correct. When you will simplify this, you will get this thing. This is positive, so it will be 5, and this must be 1 minus 5. And this is the final answer. Question number 2. The times spent by people visiting a certain dentist are independent and normally distributed with mean this. 79% of people who visit this dentist have visits lasting less than 10 minutes. From this information, you can form this equation. And with the help of this equation, you can easily get sigma. You just need to shade this area according to this sign. So you are here, therefore your number is positive. And sigma is this. Make sure you will use this number in the later part or parts. Find the probability that the time spent visiting this dentist by a randomly chosen person deviates from the mean by more than 1 minute. I discussed these things in detail in my first lecture. This statement means deviates from the mean by more than 1 minute means probability x greater than mu plus 1. So you just need to solve this thing. I'm writing this here, modulus x greater than mu plus 1. When you will simplify this modulus, you'll get this thing. I mean, basically you need this area and this area. So first, just get this area. This is 1 minus 5 and multiply this answer by 2 to get the final answer. So when you will simplify this, you'll get this thing. This means these 2 areas. So just find this area and multiply this answer by 2. So it's here. This will be 0.448 and this will become 1 minus 5 and the final answer is 0.654. If you want to understand this concept in detail, must watch my first lecture. I discussed these things in detail in my first lecture. Now the next part of this question is, this is normal to binomial, because n is 6. When n is less than 30, we use normal to binomial. N is 6, more than 2 have visits lasting longer than 10 minutes. Longer than 10 minutes means, see, this is less than 10 minutes. So longer than 10 minutes means 21%. So P is 21% in this case. So P is 21, Q is 0.79. We need more than 2. We all know how to use binomial distribution for this. This is the way to get this probability. 1 minus 0, 1, 2. That's the final answer. And this is the normal approximation because n is 35. N is greater or equal to 30 means normal approximation. Fewer than 16 have visits lasting less than 8.2 minutes. Now 8.2 is the mean. So less than mean means 0.5. See, if this is 8.2, then this probability is 0.5. So less than 8.2 means your P is 0.5. So you have to do approximation. This is the way to approximate this. So n is greater or equal to 30 and P is 0.5. Therefore, fewer than 16. Fewer than 16 means less than or equal to. This is the first possible integer value on the number line. So according to upper bound, this will become 15.5. So this is 15.5, this is NP, this is NPQ, and this is the final answer. 3 significance figure. I discussed the solution of this question in my first lecture. So I'm leaving this question. I'm just discussing this last part. Give a reason why the use of normal approximation is justified. Because both NP and NQ are greater than 5. This is the justification. When a butternut squash seed is sown, the probability that it will germinate is 0.86. This is P of binomial, and N is 250. Use a suitable approximation, that means normal approximation, to find the probability that more than 210 germinate. So the first number on the number line will be 211. According to this inequality, the first integer is 211. We always write the first possible integer on the number line. Since we are going on right side, therefore we have to take the lower bound of this number. Whenever we go right side on the number line, we always take lower bound. Whenever we go on left side, we always take the upper bound. So in this case, we are taking the lower bound. This is NP and this is NPU. NPQ. This step is very important, and especially this one. Write these correct values of NP and NPQ. This is phi, because large area is always phi. That's the final answer up to 3 significant figures. So you have to do just 2 important things. Number 1, continuity correction. Number 2, replace the values of NP and NPQ here. NP and NPQ. Question number 5. A triangular spinner has one red side and one blue side and one green side. The red side is weighted so that the spinner is 4 times more likely to land on the red side than on the blue side. The green side is weighted so that the spinner is 3 times more likely to land on the green side than on the blue side. So you have to compare red and green with blue. So if the probability of blue is x, then this will be 4x and this will be 3x, because you are comparing both green and red with blue. So just suppose probability of blue is x. When you will add all, you will get x. Show that the probability that spinner lands on the blue side is 1 upon 8. Done. The spinner is spun 3 times. Find the probability that it lands on a different colored side each time. So you just need to use simple probability R, B, G in any ways. So 3 factorial, because this is random. So that's the final answer. The spinner is spun 136 times. Approximation means normal approximation. It lands fewer than 20 times on blue side. So your P is this. This is P. And fewer than 20 means the first number should be 19. It's here. Take the upper bound. Here, NP, NPQ. and you can manage this yourself now. This is large area or larger area, therefore this is the final answer. I will discuss just part 2 of this question. A random sample of 150 people in the UK is taken. That means n is 150. Find the probability that more than 60 people are group A plus. This information will help you to take the P of binomial A plus. So there are 35% who are A plus. So P is 0.35. So P is 0.35, and the first number should be 61. Take the lower bound. This is NP, NPQ. That's the final answer. This question is simple. This is not of the approximation. You can leave this question. This is not of the approximation. This is just simple normal distribution question. The first part is of approximation. Anna meets her friend once every day. For each day, the probability that she is early is 0.05, and the probability that she is late 0.75, otherwise she is on time. Find the probability that she is on time. On time means 1 minus this and this. On fewer than 20 of the next 96 days. Fewer than 20 means the first number should be 19. Next 96 days means n is 96 and p is 0.2. So 19.5 NP, NPQ, and you all know how to handle this thing. This is 5 because this area is greater than 0.5. Larger area is always 5, smaller area is always 1 minus 5. I'm leaving the second part because the second part is not important. This is not of normal distribution, approximation question. Well, this means the simultaneous equations, I'm leaving this. 200 values of the variable are chosen at random. Find the probability that at least 160. So 160 means the first number should be 160. So take the lower bound, write NP here and NPQ here. Are less than 5. Less than 5 means get the probability from here. Greater than 5 has probability 0.15. So less than 5 means 0.85. This is your P. This is normal distribution, and this means whole number. So whenever we have whole number, we always take its lower and upper bound because we cannot find this probability in normal distribution. You can only find probability of inequalities in normal distribution of these symbols. You cannot find this. If whenever you have this equal sign, then always take lower and upper bound of this number. I discuss a type of this question in my third lecture of this chapter. So just solve this. This is 5 and this is also 5. 5 independent, this is normal to binomial. Whenever n is less than 30, we use normal to binomial. So n is 5, at most 1 means less than equal to 1 is greater than 87. So you first need to calculate this probability, greater than 87. So greater than 87, the probability is this. This is the P of binomial. Now use binomial, 0, 1. These are the possible numbers. So that's the final answer. This question is simple. I have discussed, I think 3 or 4 questions of this type in my lecture number 3. So this is k minus this is 87. You'll get this thing, since this number is positive, so this must be positive. Whenever we have positive numbers, we write phi this, and this. When you will solve this equation, you will get this answer. Well, assume that for a randomly chosen person, their next birthday is equally likely to occur on any day of the week. So birthday 1/7, independently of any other person's birthday. Find the probability that out of 350 randomly chosen people, at least 47 have their next birthday on Monday. So 46.5, this is NP and this is NPQ. And you know this is larger area, so this must be phi. First part, less than 440. So this is simple. Just need to put, this is simple question, straightforward question. Just need to solve this yourself. 94% of cans contain between this and this. Find C. Again, a simple question. When you will convert this in the form of Z, you'll get this thing. Now, just consider this part. If you observe this part, this is 3%, this is also 3%. So this total probability, this total will be 97%. This number is C upon 36, 3.6 in fact. So you can write this thing, phi of this is 0.94. So you just need to take inverse of this. Phi inverse of 0.97 is 1.881. Just equate this with this and solve this, get the answer. You can check the solution. This, less than Z is 97%. And you all know how to solve this. You need to take phi inverse of this. And then this is the answer of C. 13. In a certain country, on average, one student in 5 has blue eyes, 1 upon 5. First part is of binomials, so I'm leaving this. You all know how to solve this. I'm not discussing binomial. I'm just focusing on normal approximation. This is simple, you know how to solve this part. None is less than 0.001. You just need to take log on both sides. Whenever you take log, you change the sign because logs of probabilities are negative. For a random selection of 120 students, fewer than 33. So the first number will be 32. Take the upper bound of this, and this is NP and this is NPQ. This is phi, and that's the final answer. I'm leaving this because this question is simple. 8 people on a morning rush hour train are chosen at random. This is normal to binomial. Find the probability that between 4 and 6 inclusive are office workers. So P is 0.22 office workers, and find this probability through binomial. 300, this is the normal approximation between 31 and 49 inclusive. So the first number is 31, last is 49. Take the lower bound of this and upper bound of this. So this is 30.5 NP, NPQ, NP, NPQ. This will become phi and this will become 1 minus phi. And the final answer is 0.892. I'm leaving this question because this question, I guess, is simple. You just need to understand. This is simple question. This is not approximation. A factory produces flower pots. The base diameters have a normal distribution with mean 14 and standard deviation this. Find the probability that base diameters of exactly 8 out of 10 are between this and this. So this is normal to binomial. You just need to take out probability of this. So this will become P of binomial. So that's the final answer, 8 out of 10. This question is simple, so I'm leaving this. Okay, question number 18. 1 upon 7 is P, 252 is N. Use a normal approximation. Less than 30 or more than 44. Less than 30 is here, or means plus sign. More than 44 is here. So on number line, you have to write 29. The first possible integer is 29 and here 45. Take the upper bound of this and take the lower bound of 45. Get this and add both the probabilities. Justification, because NP and NQ both are greater than 5. This is NP, this is NQ. When both are greater than 5, then we always use approximation. This question is simple, so I'm leaving this. Again, a simple question. 18, write 17, take the upper bound and solve this. 21, part 3. The die is thrown 100 times. Use an approximation, means normal approximation, to find the probability that even number is thrown at most 37 times. The probability of even number is 1 upon 2. So P is 1 upon 2. Sorry, P is 1 upon 3. This is the probability of even number, 1 upon 3. So N is 100, P is 1 upon 3, Q is 2 upon 3, 37. So take the upper bound, 37.5, NP and PQ. That's the final answer up to 3 significant figures. I left the first two parts because they are of binomial distribution, simple probability. Plastic drinking straws are manufactured to fit into drinks cartons which have a hole in the top. A straw fits into the hole if the diameter of the straw is less than 3 millimeter. So a straw can only fit when the diameter is less than 3. The diameters of the straws have a normal distribution with mean this or standard deviation this. Our straw is chosen random, find the probability it fits, that means less than 3. This is simple. This is normal approximation, 500, at least 480. So the first number is 480 and this is the lower bound. This is NP, this is NPQ. Justification, because both NP and NQ are greater than 5. That's all. This is all from this lecture. I hope this lecture will help you to understand how to solve the questions of normal approximation well. This is an advice for me and for everyone. We should avoid sins and we should be pious. Good luck. And I strongly recommend you all, if you want to be good at this chapter, must watch all my 4 lectures on this chapter. 1, 2, 3, 4. Inshallah, you will be good at this chapter. Good luck to all of you. Allah Hafiz.